Good morning everyone. Myself K. Prashant Naik from Civil Department second year. Topic name Euclid equation Bernoulli equation. Euclid equation Bernoulli's equation. Introduction to fluid dynamics. Fluid dynamics studies the movement of the liquids and the gases and their interaction. Euclid's and Bernoulli's equation are the fundamental in understanding ideal fluid flow. The presentation covers the principal diversions and application of this equation. What is Euclid equation? Euclid equation distributes the motion of the invaded in a compressible fluid without heat transfer. It is a statement of the Newton's second law applied to fluid particles. The equation related the change in fluid velocity to pressure and body force. Mathematical formations of the Euclid equation. Euclid equation in vector form is Fox particle so on where pressure and the represented body force. The equation assumes no viscosity, making it suitable for ideal fluid flow analysis. Divergence of the Euclid equation. Euclid equation can be divided from Newton's second law applied to a fluid Pascal. In inversion, analyzing the force acting on a small value of the fluid and applying conversion of the momentum. The diversion assumption study incompressible and incased flow condition for the simplicity. Introduction to Bernoulli's equation. Bernoulli's equation relates pressure, velocity and heat in steady, incompressible and viscous flow is expression the conversion of the mechanical energy along a straight line. Bernoulli equation is the widely used in engineering for flow measured and analysis. Mathematical equation Bernoulli's equation. The equation hold along a streamline and steady, incompressible and inviscid flow conditions. Connection between Euclid and Bernoulli's equation. Bernoulli's equation can be derived from the Euclid equation under steady flow condition. It is a specific application of the Euclid equation assuming constant energy along a streamline. Both equations highlights the relationship between pressure, velocity and evaluation in fluid flow. Particles application of the Euclid and Bernoulli equation. These equations are used in designing aircraft, winning turbines and piping system. They help analyze flow in veterinary meters, nozzles and other fluid machines. Understanding this principle aids in the optimizing fluid transport and energy efficiency. Limitation for Euclid and Bernoulli's equation. They assume inviscid, incompressible and steady flow which may not always be realistic because effects, turbulence and compressibility can cause deviation from predictions. For real and world applications, additional coordination or more complex models are often necessary. Conclusion and summary. Euclid's and Bernoulli equation are fundamental tools in fluid mechanics and ideal flow analysis. They provide insights into the relationship between pressure, velocity in the energy in the fluid. Masters of this equation is the estimation for the engineers working in fluid dynamic and related flights. Thank you.